Suspension plays a very important role in giving an automobile the aesthetic feeling of comfortness. This is done by gradually damping the jerks that the vehicle encounters upon its journey. So, when a vehicle is moving along the road and it suddenly experiences a bump, then we don't want the damping constant to be very high, but we want it to be low. This is because a low damping creates sinusoidal disturbance and a high damping constant, which would lead to the passengers experiencing the bump as it is without its effect being minimized. However, after some time, we want the car to become stable and not keep oscillating. Hence, we want the damping of the vehicle to gradually increase over time.
Okay, so now there are two types of suspension mainly. The first one being the normal shock absorber. So what happens in this is that this is the spring type suspension that you see in red color. This is the shaft. So when the vehicle experiences a bump, so these two they come closer to each other, and then this oscillation is damped out with the help of this spring. Now the spring has a definite constant. So the entire oscillation they are damped out by the same amount irrespective of the intensity of the shock that the vehicle experiences. The second type of suspension that is a viable solution to this problem is the magnetic ride suspension. This contains a fluid which has oil and metal. Why it contains metal, that we'll see later. This contains a piston. Now, for the fluid to flow from one chamber to the other, it needs to have some holes or some gap. That is done by these black colored piston channels. This is the shaft. One more thing, in the piston there is an electromagnet. Now to power the electromagnet, we need voltage. So those electric cables, they run through this cylindrical pipe that you can see. Now, when no voltage is applied, no voltage is applied and the vehicle experiences a jerk. So these two cylinders they come towards each other and the fluid from one chamber can easily flow to the other without any interference. But when we apply certain voltage through this rod to the electromagnet, what essentially happens is that this piston channel it experiences a magnetic field in this direction. Now the oil and the metal that are passing through it, which were initially randomly, they now get oriented in the direction of the magnetic field. What this leads to is that it restricts the flow of the free flow of oil. So in this way, the damping constant of the suspension increases. This is how we can control damping with just the voltage.
Advantages: they're active as in they work in real time. They're also fully adjustable, as the amount of damping can be changed by changing the magnitude of the voltage, and they have variable damping, as the magnitude of the damping can be varied according to the size of the bump, or it can vary according to the situation. They have fast response, as in it is a simple circuit in which by varying the voltage we can change the flux, which in turn changes the magnitude of the damping. And they have independent control at each wheel, meaning that they can vary independently at both the wheels according to the situation. And the only disadvantage they have is that the process of making them is a very complex, and hence it is costly. And if you look at the uses of dampers, it's vividly used in the automobile industry, and also also in the military. Thank you, and I hope you understood the basic concepts of magnetic ride suspension, and that was it.